Lightning is a dramatic natural force. But what causes it? On a smaller scale, a spark can be produced in the lab. Sparks and lightning are both a flow of charge. In each case, the charge is built up by friction. Some objects can become charged simply by rubbing them. The charge on this plastic rod is too small to form a spark, but big enough to attract pieces of paper. And big enough to influence the path of this stream of water. To find out why the rod becomes charged, you have to think about what's happening to the atoms it's made up of. Atoms contain positive charges called protons and negative charges called electrons. Normally the number of protons and electrons is the same, so the atom has no overall charge, it's neutral. Friction between the cloth and rod changes this balance. In this case, the cloth rubs electrons off the atoms in the rod, so the rod becomes positively charged. A Van de Graaff generator produces enough charge to generate a spark. Take a look inside and you can see a motorised rubber belt. It passes around a Perspex roller at the bottom and at the top. As the belt rubs against the roller, it acts like the cloth on the plastic rod. It rubs off electrons, leaving the rod positive, while the belt becomes negative. The electrons are collected by a spring and transferred to the metal dome. Because it has nowhere else to go, the charge builds up. It can't move from the dome, so it's called static charge. Place a conductor near it, like this small metal sphere, and the charge can move. It leaps across, producing a spark. Charge builds up on anything in contact with the dome. Each fibre of Lindsay's hair becomes negatively charged. Like charges repel, so they move as far away as possible from each other. But for this to work, the charge needs to be static. It mustn't leak away. Standing on polystyrene blocks acts as good insulation. What would happen if Lindsay stepped down onto the floor? The generator produces some interesting effects, but can you explain how? Why do the polystyrene balls rise and fall? What's causing the bulb to light up? Connecting a wire to the dome provides a path for the charge to flow along. It travels through an ammeter, which is connected to the base of the generator to complete a circuit. The ammeter registers a flow of current. Electricity is simply a flow of negative charge. Static electricity becomes a flow of electricity as soon as it's able to move. A fluorescent tube held next to the charged dome flickers as a current flows. But static electricity can cause problems. Every time an aircraft takes on fuel, there's a build-up of charge as the liquid rubs against the rubber pipe. To prevent the charge causing an explosive spark, a wire is connected between the tanker and the metal body of the aircraft before the fuel is pumped. The line ensures that no charge can build up on the plane. Both tanker and plane also have special tyres which conduct electricity to the ground. A similar charge builds up as the plane rushes through the air, rubbing past air particles. To discharge this build-up of static electricity, they have small metal spikes on the edges of their wings. These provide an easy route for any charge to leak away. Lightning is a giant flow of electric charge from a cloud to Earth. But where is the friction that causes it?